Okay, very good morning. So we already started discussing about the wear mechanism, correct? So in that we already discussed what is meant by wear and what are its functions and analysis, and also we discussed types of the wear. And in that we discussed about adhesive wear and abrasive wear and their mechanical and lubricant uh, prevention method. So next type of wear is erosion wear. So have you heard the word erosion? So it's the erosion wear. So the erosion wear, close the door. Erosion wear, the cutting off. So cutting off same. It's a flow type of cutting. That is what we discussed in our yesterday's class. It's a ferrous. It's a ferrous type of cutting. Means it will flow off the hard particles, flow off the soft particles. It is called ferrous type of cutting on the surface by hard particles. You can see here, surface by hard particles containing a fluid traveling at a high speed. Means the fluid means the lubricant which contain a foreign particles or abrasive particles or dust particles, and they are moving with a high speed because it is along with the fluid, it is also moving with a high speed, and those particles start hitting on the surface, hitting on the smooth surface of the anyone, either bearing surface or journal surface or any two meeting surfaces. Okay, you can see here it is a foreign particles along the fluid. Okay, it is moving with the same velocity of the fluid, clear, and it is hitting on the any one surface, and because of that hitting with a high velocity it creates the scratches or indentation on the surface, clear, and this type of wear is called as erosion wear. So erosion wear, it is just due to because of hard particles containing a fluid traveling with a high velocity, and it is causes the ferrous type of cutting, just like a previous abrasive cutting. Okay, you can see here in this a particle hardly hitting on the surface and it creates the indentation or scratches that you can see in the microscope. So this is what we call as a erosion wear. And how we are prevent this erosion wear? That is by removing those hard particles in the fluid. By removing the hard particles in the fluid by filtering or cleaning, and just free from the any foreign particles. That is one thing. Second thing, reduce impact angle less than 50 degree. Impact angle means this angle, hitting angle. Okay, so we have to reduce the this angle less than 50 degree. It won't causes a much indentation. If it is increase the angle, it will damage more. Clear? So that you have to reduce the what angle, impact angle, and increase hardness of the metal surface. That is another way of prevention is by increasing the hardness, that will absorb the whatever the vibrations, whatever the energy hitting on the surface, that will absorb by the hard surface, so that ultimately it won't produce any indentation or scratches. That is what we discussed in the hardness test, correct? In the hardness test, what you are going to check the hardness of the material by making with the help of the ball indenter or a diamond indenter and applying the pressure. So it causes the indentation. Okay, if it won't produce any indentation means it is a very hard surface. If it is produce a indentation, it's a soft surface. Okay, so here also same thing, we have to provide a very hard surface so that it prevents the whatever the indentation or scratches produced by that erosion wave. Okay, so these are the mechanical ways, and whatever the lubricant way, that is by use oil free abrasive particles. That's one thing. The oil should not contain any foreign particles. And remove viscous oil. If it is a more viscous, use more viscous, what happens? Yes, it will avoid the wear. It will separate the two surfaces. So use the more viscous oil. If it is a less viscous, obviously the flow rate is more and the impact also more. So use less, more viscous so that it will reduce the flow rate. Clear? So these are the mechanical and lubricant way of to reduce the erosion wear. That is the third important erosion wear. So next is a polishing wear. So polishing wear, you already seen what is meant by polishing. Making a smooth surface, rough surface into smooth surface by slowly removing the particles on the surface. This is that you can see in the in your grinding, okay, owning operation or specimen preparation. In the wear testing, you are going to prepare the specimen or microstructure in the third semester empty lab. Okay, if you want to see the microstructure first, that specimen thoroughly polished, then only you can able to see the microstructure. Okay, so polishing means a removal of very small material on the surface. So polishing where it is a continuous removal of surface, a film or a laid down via chemical reactions. It is through the chemical reactions. It's a continuous process, but it is a small amount, but and it is because of chemical reaction from the additives in an oil or by a very fine hard particles in the lubricant. It is due to just because of the chemical way of wear. Okay, so this lubricant is either react with the hard particles or a foreign particles or any one surface, and because of that chemical reactions, it is a continuously the wear will takes place. Clear? And polishing wear is a characterized by a very shiny. Okay, of course, it's a very shiny surface. Okay, ಇದನ್ನೆಲ್ಲಿ ನೋಡಿದ್ದೀರಾ? In your brake liners, in your clutch, okay, continuously wear off, and if you see that the surface, it's very shiny. Okay, it's the best example for polishing type of wear. There is a wear takes place, but the surface is very shiny. But in the previous, the wear takes place, but the surface is either by the indentations or any type of flowing is takes place. Correct? But here there is no flowing, there is no indentations or nothing. But here there is a continuous wear. It's a small wear rate, and it produces a very fine surface, shiny surface, a smooth and mirror-like surface. Yes, you can see here. It's a type of bearing, okay, and this bearing operating with a different conditions. And here you can see this, okay. Can't you hear? So this is what the shiny surface. So this shiny surface is generated or it is created by polishing type of way. Okay, it is not intentional. It is because of a one type of wear. You can see here a bearing continuously operating, or else you can clutch plate, brake liners. Okay, there you can see the very fine mirror-like surface. It is because of the polishing type of wear. Okay, and mechanical, there is no mechanical way to prevent, but in the lubricant choose the less chemically active additives. In that lubricant you have to go with the less chemically active lubricant. Okay, it's a one way. Second way, remove the corrosive contaminants, okay, and remove the abrasives. If you remove all these things, and it prevents the which type of way, it prevents the polishing type of way. Clear? The contact fatigue. It's a contact fatigue. We know that already. Fatigue load means it's a cyclic load. Fatigue means impact means sudden. Okay. Fatigue means it's a continuous, it's a cyclic load. Once it is increases, once it is decreases continuously. Okay, with respect to the time, the load increase, decrease, load increase, decrease. That is called fatigue. Okay. So here it is a contact fatigue. The crack, fittings or spalling of surface in the sequence due to the cyclic stresses. It is just due to the cyclic, means continuous. With respect to the time, the load increase, decrease, amplitudes increase, decrease. That is what a cyclic stresses in the contact when they are in the contact. The contact fatigue is the most common in rolling elements, bearing, gear teeth, and cam. And this is what more common we can see in the cams. I think you already gone through the cams. The cams, there are different cams. There are continuous, cycloids, SHM. Okay, have you seen cam? There are different types of the cycles continuously. Okay, so here it's the best example that cam undergo there are a cyclic or a fatigue type of load. Okay, when the fatigue type of load, there is a sequence of load is operating on that bearings or a gear or a cam that creates the cyclic stresses. That load creates the cyclic stresses, and that stresses is accumulated in the component, and it will causes the continuous wave. Clear? And how we can prevent, that is prevent by reduce the contact pressure. By reducing the contact pressure means continuously there is contact. If you reduce that contact pressure, it will reduce the stresses. It's a one way. And next, use the high quality vacuum melted steels. If you with a that is what bearing materials, if we use high quality melted steel, that's another way. And use less abrasive surface finish. Okay, if you make the smooth surface, if it is a rough surface, again it will cause us. If it is a smooth surface, it will reduce them. And next is a lubricant type. Use the clean and dry oil. So this is a what common solution. Use the clean. If it is a clean, it will prevent so many types of waves. Okay, and use oil with a high pressure viscosity coefficients, and use more viscous oil. It is also one of the common utilize. You have to use always more viscous oil. If you use more viscous oil, we can reduce the contact fatigue, we can reduce the polishing wear, we can reduce the fatigue wear, we can reduce the abrasive wear also. Okay, always you have to use clean and more viscous oil. And next come to the corrosive wear. So corrosive wear, we already seen that corrosive wear means it is because of the a moisture contact with any one of the surfaces. It forms the a layer called rust. Is it correct? It forms the layer called rust, and that rust will continuously wear off or rub off. Okay, so that type of wear is called as a corrosive wear. Corrosive wear, it's a removal of corrosion product from the surface by the motion such as a rubbing of the rust. Means if the any one of the surface is very sensitive, and when it is contact with the moisture, okay, it forms the rust, a rust layer. Rust means it is a reaction between the water particles as well as the surface, and it forms the one layer. That layer is a wear. Okay, it's the loss of material, and that layer is, when it is contact with any other surface, it will rub off. Okay, it will waste. It is also a type of waste, and it is can reduce by or prevent by first use more corrosion resistant material. That material itself having a more corrosion resistance. Example, if you go with the ceramics, okay, if you go with the ceramics polymers, the polymer and ceramics, the where the corrosion is very less. If you go with the aluminium, the corrosion is very less. But if you go with the steel, corrosion is more. So go with a corrosion resistant material. That is what? Preferably a not a stainless steel, but instead of stainless steel, you can go with the any ceramics or any other material. That's a one way. Next, reduce the operating temperature. Of course, operating temperature is also one factor which increases the corrosion. If more the temperature, what happens when it is come into contact with the lubricant? That lubricant will, because of the high temperature, it may forms the any moisture or water particles, and those water particles may uh, destroy the surface by forming the rust. Okay, so that to reduce the operating temperature. If it is reduce the operating temperature, then it won't form any rust causing elements. and eliminate corrosive materials. If any corrosive materials, you have to eliminate those things. That is what the mechanical way of. And lubricant, remove corrosive materials such as to chemically active additives or contaminants. In the lubricant, if any chemically active additives, you have to remove those things by the lubricant and try to avoid the any other contaminants which causes the corrosion. And use improved corrosion inhibitors means uh, some other substance if you use along with the lubricant that will avoid the formation of corrosion. That is what inhibitors. If you use those things, it will automatically reduce the corrosion formation. And use a fresh oil. If you use the used oil, of course it contains some sort of contaminates, and also it is already loses its chemical stability. So always if you use a fresh oil, it will solution for prevention of corrosive wear. Clear? So electrocorrosive wear. It is a combination of electro means electrons as well as the corrosion. It is also a very this type of wear is very less. It is less than 1%. Overall 100% failure, and this type of electrocorrosive wear contribution is less than 1%. Less than 1%. It is very rare type. Okay. And here electrocorrosive wear, the removal of metal by dissolutions in the corrosive liquid means that metal is dissolved in the liquid and it will loses its ions, positive and negative ions. That is what when it is along with the some solutions, it will start dissolving its ions or its atoms. That is what the electrocorrosive wear. Okay. And one source of the current, and this is for one source is current. If you supply the current, okay, it will start dissolving its ions or atoms. And the oil severs as the electrolyte. If the more oil is there, that will act as an electrolyte and it will start dissolving the atoms. If the atoms are dissolving means indirectly it will lose of material. If the lose of or loss of material means it is what? It is a wear. Okay. If any material is lose means loss means it is a wear. And here the atoms is losses or ions is losses. Indirectly, materials is also losses. And the prevention is decrease a liquid velocity and velocity gradients. Okay, you have to decrease the liquid velocity means it is a flowing rate. You have to reduce the flowing rate, one thing. Second, use corrosion resistant materials obviously, and eliminates the steady current means a steady current. It is a you have to reduce the steady current on the elements. You are already clear what is eddy current and all things. Okay, if the current is there, it will start loses its ions or atoms. That we have to reduce. Lubricant, decrease or increase the electric conductivity of the lubricant. If that liquid is having an electrically conductive, okay, either you have to decrease or increase the electric conductivity of the lubricant, hydraulic fluids. Okay, if you want it is conductive means what happens? If it is electrically conductive means it will destroy the surfaces. If it is non-conductive means it won't react with the current and it won't dissolve the element in that. Okay, so that you have to decrease the electric conductivity of the liquid. Clear? And this is what the microscopic uh, uh, surfaces. If you observe with the help of SCM, SCM means scanning electric microscopy. If you see in that, these are the surfaces. By naked eye, it is just like a very smooth fine surface. But if you see in the microscope, you can able to see these are the scratches. Okay, just because of the rubbing wear. So the first one is because of the rubbing wear. Second one is a cutting wear. It's a second one because of cutting wear. Some of the particles cut the surface, cutting. Here you can see the lines, continuous lines, okay, parallel lines because of the rubbing surface. And here there is a crack. It's just because of the cutting wear. Okay. Next, fatigue wear, sculpting wear, corrosive wear, abrasive wear. So abrasive wear you can see in the grinding. Okay. So these are all different types of wear that you can see through the microscope. Okay, and these are the wearing damages classifications according to the ISO. These are the types of wear, and because of the type of wear, what are the surfaces loses. Okay. So with this, we discussed so many types of wear. The first type of wear is adhesive wear. Second type of wear is adhesive wear means one surface going to adhesive on the another surface, bonding over the another surface. That is called the wear. Second, abrasive wear means any one surface containing a hard surface projection that will block the another surface or any other contamination from the foreign particles that will create the scratches on the other surface. It is also a abrasive wear. Next type of wear is erosion wear. Erosion wear means because of erosion, what? Because of the a chemical reaction on the lubricant, it will slowly continuously loses the surface. That is what erosion wear means. Some of the hard particles in the lubricant that will hit on the surface that creates the scratches or indentation. That is what erosion wear. And next type of wear is polishing wear. It is also a continuous and slow process. Okay, it is also because of the chemical action in the lubricant. Continuously, it will remove and it causes the surface very fine and smooth and shiny surface. Okay, and next type of wear is corrosion. Corrosion wear, it is a reaction takes place and forms the rust layer. Next is Next is contact fatigue wear. It is a cyclic stress induced in the two surfaces. It causes the wear. And the last type is electrocorrosion, where because of the current, it will destroy the items or ions or atoms in the surfaces. It causes the wear. That wear is called as the electrocorrosion wear. Clear? Uh, and the next important thing is one of the theory is there. Okay, just to analyze the a type of wear, and this theory is called as the delamination theory of wear. So this theory used to prevent the wear. It's not 100% eliminates, it only prevents the wear. Okay, so for the prevention of wear, we are going with a one theory. That is what an important theory. It's important and it is there in your syllabus. The delamination theory of wear. Okay, and this theory is belongs to the approach where how the wear is takes place and what are how the step by step the wear will takes place. Okay, if you understand this theory, you can prevent the wear. Means this theory provides the first step, second step, third step, and fourth step. Of course, first step is final damage. If you analyze in the first step, you can eliminate the wear. If you analyze in the second step, if you analyze in the third step, means severity. If it is a fourth step, it's severe. If it is a second step, somewhat less severe. If it's a second step means or first step means it's a mild. Okay, mild where we can reduce or prevent. Clear? So wear is just like a cancer. Correct? For a human body, if the cancer is there means it will continuously destroys the organs and ultimately leads to the death. Correct? Similarly, for the any components or devices, this wear is just like a cancer. It's a continuous, it's a slow process and continuous. Okay, and finally, if it is in the severe means it will damage or destroy the entire component. Okay, or failure of that component. If it is in the first stage, we can easily eliminate the wear and increase the life. Just like a cancer, if the first stage, second stage, third stage. Okay, if it's a cancer in the first stage, we can easily cure it. If it is a third stage, even also you can cure. If it is a fourth stage, we cannot. Similarly, same way, it's just like a cancer for a components, mechanical components. A wear is a cancer for mechanical components. If it is a through this theory, we can analyze if the first stage or second stage or third stage. If it is a first stage, we can easily reduce or prevent the final failure. Clear? And of course, it's having some step. The first step of this failure is this theory. I'll just explain in the brief. Okay. So this theory having in 4 steps. The first step is a plastic deformation. A plastic deformation of the surface. Second step is a crack nucleation. Third step is a crack propagation. And the fourth step is it is a failure or formation of or creation of sublayer. A creation of sublayer on the material. Clear? So these are the 4 important steps in the delamination theory. The first thing is a plastic deformation. Means wear means it is a permanent deformation, correct? So materials always having 2 properties. One is the elastic and another one is the plastic. So elastic means once you release the load, it will regain all its original size and shape. If it is not regain its original size and shape, it is called as a plastic. Plastic means that is a permanent deformation. So here also where it's the first stage is a plastic deformation. The plastic deformation of the surface. Okay, the plastic deformation. Second stage, because of the plastic deformation, there is a small crack initiation. Clear? If there is a big crack is there means it won't create as it is a big crack on the wall. Correct? Or else you can see any cracks. You can take example in your tensile test. Best example is tensile test. What you are going to do? You take the specimen, a one ISO standard specimen, okay. On that, you are going to apply the tensile load. Tensile load means first it starts with 0, 100, 200, 300, 400, like continuously you are increasing the load. And what happens? Is there any sudden fracture? Or if you apply the 0 load or a 100 load, it will fracture the specimen? No. When it is fracture the specimen, once the load is crosses its ultimate strength of the material, then it will cause the fracture. So before going to fracture, it will provide some indications. Like first, it will reduce the diameter, okay, increase the length. That is one thing. Second thing, a small crack will propagate, okay, and that crack again continuously decrease the diameter. Is it correct? And ultimately, if you increase the load, that will fracture with cup and cone arrangement in case of mild steel. Correct? Before going to fracture, it will heal. Plastically, it will heal. Means there is a one small crack, a one small point of a crack that is for the source of the failure. Is it clear? Any component in the mechanical, we cannot eliminate the point crack. Means because of the manufacturing defects or whatever, because of the surroundings, there is a one small source for the crack. If we apply the load on that crack, that point will start growing. That will start propagate into the specimen, and ultimately once the load exceeds, it will fracture. Correct? Here also same thing. First, there is a plastic deformation. Second thing is a one point. Because of the plastic deformation, one small point, a voids, a one small point of voids, okay, that will start propagating. It is just a one point, okay, like this. Here, one point, and it will start because of a continuous operation, because of the load, because of the speed, okay, because of the environment, that a small point will start propagate, will increase the length. Clear? And third step is crack propagation. Crack initiation or nucleation. Nucleation or initiation means a small voids is become a crack source. Third point is that source will start propagate, will start increase. Clear? And in the fourth stage, what happens? That entire propagates. Okay, propagate means it's already formed and forms the sublayer. One metal is there, and on that metal it forms the another sublayer. Okay, so here a small crack that propagates, and it will separate the two layers, a base material and another sublayer. Okay, and this sublayer is a, once the load increases, this sublayer will ಏನಾಗುತ್ತೆ break down. Break ಆಗುತ್ತಾನೆ. It's a mobile. Okay, so I'm applying a cover. So this cover is just like a sublayer. Can you understand? This mobile is a specimen. Okay, and here one small crack is there. Okay, because of the operating load, this crack will start propagating and start separates this entire specimen with this cover. So you know it is nothing but a wastage of material. That loss of material. That loss of material is called as a wave. Is it correct? It's a loss of material. This layer is a part of this specimen. Because of this crack, because of the crack and load, it will separate from this material, this specimen. So it is called as a wave. And it is a step by step. First, we have to initially, if the plastic deformation, we can observe the surface. If it is a plastic deformation, we have to reduce the load, we have to increase whatever the necessary action we can take. If you take the necessary action, it will reduce the weight. If it is a small voids, if you avoid those voids, it will reduce the crack formation. If there is a crack, we can take some preventions, we can reduce the failure. If already it forms the sublayer means, we cannot do anything. It ultimately wear off, lose of material. Clear? That is what the delamination theory of wear. And here during the wear, dislocations. That is what a dislocation means, a voids. Okay, a dislocations will takes place, and the material due to the plastic deformations of the surface by the slider. It's either sliding or rolling, whatever it may be. Any type of wear. Okay, either sliding or either rolling. And if an oxide layer will broken by the passage of slider, thus exposing the fresh, a clean surface. That we can see by, it's just a proof for the wear. Means any, if you take any wear of material, okay, so on that there is a one sublayer. If you just remove that sublayer, you can see the fresh surface. It is an evidence for, delamination theory. Okay, that wear takes place according to the delamination, means layer by layer, sharing of the material layer by layer. Okay, so that sublayer, there is a sublayer. Okay, it is may get corroded. Okay, whatever it may be, and if you remove that sublayer, you can see the very fresh and clean surface. Clear? That provides the evidence for this delamination theory. And with a continued sliding, there will be the peel off, the dislocations at a finite distance from the surface. Time this leads to the formation voids and will enhance the material continuous and hard second phase, and dislocation will present. Means here it is also a type of evidence. Whatever these things are, they are providing the evidence for this dislocations. Dislocation means voids. Okay, and these voids are step by step will increase and forms the sublayers. If you go with continuous with the same operating conditions, and finally it will get fracture. Okay, and these voids can also form by a gross plastic flow of matrix around the large hard particles. Maybe because of the voids, because of the hard particles. Okay, whatever the hard particles surrounded by, okay, some plastic materials, it may causes the voids. For reason for voids is many reasons. Okay, the voids may be because of the manufacturing defects, voids may be because of the other time of operating conditions, voids may be because of the hard particles sitting on another surface, or maybe because of the chemical reaction, whatever it may be. The source for voids is an n number of reasons. Okay, when its crack reaches the critical length. When the crack reaches the critical length, okay, what happens depends upon the material. Okay, if it is a continuous, it's having some critical length. Okay, and that material between the crack and surface will shear up and producing the sheet-like particles. Means when the crack means it will continuously propagate. It will continuously growing. Propagation means it will continuously grow. Clear? It continuously grows, just like the specimen, tensile specimen. The small voids, if we continuously apply the load, that the voids will start in the form of crack, and the crack will continuously propagate or growing until it get fracture. Correct? Here also same thing. This crack length reaches a critical length where it cannot grow further. That is what the critical length, and that it will form the sheet-like particles. A sheet like a particle means sublayer forms the sheet-like particles means we call it as a sublayers. And those sublayers, because of the action, they will break off. They will break off and they will wear off the material. And that layer will break off. Again, there is a fresh layer. Again, on the fresh layer, again plastic deformation, voids and propagation, and sublayer. Again, they will break off. So in this way, wear will take place. Clear? Is it clear? And behavior of dislocations near the surface. You can see oxide layers. These are the oxide layers and sliding direction. Okay, and here it will shear up. These particles will shear up this oxide layers. Crack and wear sheet formations. Here you can see it's a one surface, a hole, that is what the voids present here. Sliding directions, slider A. Okay, elongated holes. These are the small holes, and because of this action, it will continuously elongate. See, here it's a small hole, but because of that, it will start propagating. Holes are propagating. And hard particles, these are the hard particles. And these cracks will continuously grow and forms entire this surface. This surface is separate. It is become a subsurface, just like a sheet. And particle size and formation around the particles, okay, on that hole, and wear of the hard surface and deformation of the cell. It is the final action. Here, this is what the delamination theory.